All right, welcome to screencast number 1 for Unit 8, Lesson 5. This lesson is something that I gave you guys a copy of. It's not part of the textbook material because your textbook, for whatever reason, doesn't talk a whole lot about severe weather. So we're going to cover that. We're going to start off with thunderstorms. All right. It is estimated that there are as many as 40,000 thunderstorm occurrences each day worldwide. This translates into an astounding 14.6 million occurrences annually. And the United States certainly experiences its share of thunderstorms. All right, so here is a map of the United States. And blue would be fewer thunderstorms. Orange, red are more thunderstorms. Okay, the figure above shows the average number of thunderstorm days each year throughout the U.S. The most frequent occurrence is in the southeastern states, with Florida having the highest number of thunder days, between 80 and 100 per year. Okay, we in Lexington sit right about here. Okay, so between 40 and 50 or so thunderstorm days per year. Okay. I might refer back to this map, so just keep it handy. Okay, let's go on to the next page. All right. It says in this part of the country, meaning the southeastern United States. Southeastern United States is, remember, we're talking about this area, okay? In the southeastern United States, moist air from the Gulf of Mexico and the Atlantic Ocean is most readily available to fuel thunderstorm development. Okay? And it's pointing out that warm, moist air is going to be one of our big necessary ingredients for the formation of thunderstorms. Okay? All right, so now we're going to talk about the necessary ingredients for thunderstorms. All thunderstorms require 3 ingredients for their formation. Moisture, meaning we need water vapor in the air, instability, and a lifting mechanism. Okay, so some fancy terms, but we're going to walk you through what that means. First ingredient required for the formation of thunderstorms is moisture. All right. Typical sources of moisture are large bodies of water, such as the Atlantic and Pacific Oceans, and in our area of the country especially, the Gulf of Mexico. Okay? Please remember that the Gulf of Mexico is this body of water down here. The Atlantic Ocean is here. The Pacific Ocean is over here. And we will find out in a little while why this area of the country, even though it sits next to the Pacific, does not experience as many thunderstorms as the Atlantic side of the country. Okay. All right, so we need a source of moisture, and those are going to be large bodies of water. Water temperature also plays a large role in how much moisture is in the atmosphere. Okay. Warm air can hold more moisture than cool air. Okay. And you're going to have warmer air associated with the air right above warmer ocean water. And recall that warm ocean currents occur along the east coast of the continents, and cool ocean currents occur along the west coast. Again, let's go back to the map. Along the Atlantic, this warm current is the Gulf Stream. Do you remember that? It is a warm water current. On the opposite side, along the Pacific, we have a cold water current called the California Current. And that is why we don't have as many thunderstorms on the west coast because that is a cool current, cooler water, less moisture is evaporating into the atmosphere above, and we're going to have fewer thunderstorms. On the other hand, we have warm ocean water over here, which is going to help with thunderstorm formation. Okay, so evaporation is higher in warm ocean currents and therefore puts more moisture into the atmosphere than with cold ocean currents at the same latitude, which is what I just showed you. Therefore, in the southeastern United States, the warm water from the two moisture sources, which is the Atlantic Ocean and the Gulf of Mexico, helps explain why there is much more rain in that region as compared to the same latitude in Southern California. Okay? All right. So ingredient number 1, remember, was moisture. We have to have a source of moisture. Okay? I want you to underline this sentence also, just to remember that. Okay. And in our region of the country, remember that it's primarily the Atlantic Ocean and the Gulf of Mexico, especially here in Texas, it's the Gulf of Mexico, that are going to provide that moisture for us. All right. Second ingredient required for thunderstorms is a source, or the fact that air can be unstable. Okay, so it's the fact that it's got instability. Air is considered unstable if it continues to rise when given a nudge upward, or it continues to sink if given a nudge downward. It's sort of like, think of inertia of an air mass. Once you get it going, it's going to keep going and doing rising or sinking, whatever it started doing. Okay, so air is considered unstable if a little nudge gets it going up or down. And unstable air masses typically are characterized by warm, moist air near the surface and cold, dry air aloft. Aloft meaning higher. Okay? Because it's going to be very, very easy for us to put that air in motion. Warm, moist air is generally going to be less dense than cool, dry air. And so once we get it nudged into motion, it's going to start rising and forming clouds. Okay, so let's go on. All right, and that's basically what it says up here. In these situations, if a bubble or a parcel of air is forced upward, it's going to continue to rise on its own. As this parcel rises, it cools and some of the water vapor will condense, forming the familiar tall cumulonimbus clouds that is the thunderstorm. A cumulonimbus, those are thunderstorm clouds. Those are the big, tall, puffy ones. Okay. All right. Just to remind you, we've got all thunderstorms require 3 ingredients: moisture, instability, meaning we can get it going if we just nudge it a little bit, and we need a way to get it going, a lifting mechanism. Okay, so we're going to talk about that. Sources of lift. Okay. Typically, for a thunderstorm to develop, there needs to be a mechanism which initiates the upward motion. There needs to be a way for us to get the air moving upward. Something that's going to give the air a nudge upward. This upward nudge is a direct result of air density. Okay, so some of the sun's heating of the Earth's surface is transferred to the air, which in turn creates different air densities. The propensity for air to rise increases with decreasing density. Okay, what that means is the tendency of air to rise, okay, it's going to be more likely to rise when its density is lower. Okay, less dense air is going to rise more easily, in other words. Okay, so this difference in air density is the main source for lift and is accomplished by several methods. Okay. Differential heating, meaning that the sun's heating of the Earth's surface is not uniform. For an example, a grassy field will heat slower than a paved street. A body of water will heat slower than a nearby landmass. Okay, so main sources of lift. Differential heating Boundary lines, such as fronts, dry lines, outflow boundaries. All of these act as boundaries between different air masses. And when air masses interact, the less dense one is typically going to be forced upward. Also, you can have lifting due to terrain, meaning the shape of the land. As air encounters a mountain, for instance, it is forced up because of the terrain. So upslope thunderstorms are common in the Rocky Mountains during the summer, for instance. Okay? So sources of lift, the fact that we don't have uniform heating, that we have boundary lines between air masses, and then we have different areas of terrain. Okay? All right. We're going to start talking about the life cycle of a thunderstorm. Okay. Building blocks of all thunderstorms is the thunderstorm cell, these big cumulonimbus clouds. Okay, cumulo kind of means towering, nimbus means rain. Okay, the thunderstorm cell has a distinct life cycle that lasts about 30 minutes. Okay, you have the towering cumulus stage, where the cumulus cloud begins to grow vertically, meaning it gets taller and taller. And air within that cloud is dominated by updrafts. Updrafts meaning strong winds that are going up. Okay. Then we have the mature cumulus stage. The storm has considerable depth, often reaching 40 to 60,000 feet, miles and miles and miles deep. Strong updrafts and downdrafts exist. Okay. Updrafts are strong upward winds, downdrafts are strong downward winds. Okay? This is the most dangerous stage when large hail damaging winds and flash flooding may occur. And then, after the storm sort of wears itself out, we have the dissipating stage. Dissipating means it's kind of going away. So the downdraft cuts off the updraft, the storm's no longer has a supply of warm, moist air to maintain itself. Okay, and therefore it dissipates. It kind of slowly goes away. Okay, and that's what this page down, this illustration down here is showing you. You have the towering cumulus phase where you have a lot of vertical development. These clouds are getting taller and puffier. You have the mature stage, okay, where you have both updrafts and downdrafts, and you have a lot of stuff going on. You have heavy rain, possibly hail, things like that. And then you have the dissipating stage, okay, where it's sort of slowly going away. Now, it doesn't tell you this, but up here, this is the approximate location of the top of the troposphere. The troposphere is the bottom layer of the atmosphere where our weather occurs. And it's kind of like when the cumulus clouds get to the top of the troposphere, they can't go any higher. And that's because the characteristics of the next layer, the stratosphere, changes. And so it kind of hits a glass ceiling, if you will. Okay? So a lot of times when you see these cumulonimbus clouds and they reach that maximum height, that's marking the top of the troposphere. Okay?